Hello, Professor B back here with a look at data visualization. As we move forward in our careers as technical writers, there's a good chance that we might want to display our data in a visual fashion to our users. In this particular case, we'll be looking at graphs and charts and some ways we can best answer the questions that we might be getting from our readers, or we want to explain away the question ahead of time so they don't have to ask it. It's a very short slide deck, about 10 minutes, and hopefully there are several tips and tricks you can get out of it. So without further ado, let's dive in and take a look.
Data visualization, an incredibly important topic when dealing with technical writing, because we all know that a picture is worth 1,000 words. But what if the 1,000 words are not worth reading? There are several tips and tricks that we have in this presentation. We'll go through them and point out some good and some bad and maybe some ugly. So let's dive right in. How do we want to communicate to our audience a good story? That is what we're looking at here with these examples. And then we'll look at 5 ways that you as the author can actually mislead your reading audience with some missteps on your part. So the first example here is when we are tasked with the question, how has the reading in America declined from 1978 to 2014? The author gives this chart on the screen as the first attempt at it. You can see 3 different categories: Pew Research, Gallup poll in 1978, 1990, and 2014 respectively. You have the blue colors, and this is indicating how many books did Americans read in the last year. Along the bottom x-axis, we have categories of none, 1 to 5, 6 to 10, 11 or more, and no answer. Well, this really clouds the answer that we're trying to get to. We have a lot of extraneous information in here. So let's scroll forward and see how we might refine the data we put on the screen or in the chart or in the graph and the way we're trying to answer the question. How many books did Americans read in the last year? So we're asking the question between 1978 and 2014 based on the survey. So the 1990 poll has absolutely no meaning for us. We want to take it out completely. Now we are just showing our categories in the first year of our question and the last year of our question. It's a little better. Well, let's move forward again and change the visual story up. Okay? We're asking ourselves, how did it change from 1978 to 2014? So here is a better visual depiction of how it actually changed. In the first question here, we got 23% of Americans read 0 books last year in 2014. That is a marked increase from 1978, when only 8% of Americans had not read anything. And the heavy readers are also down. So people are reading less. You can see in 1978, 42% people had read more than 11 books in a year. And in 2014, only 28%. Very quick snapshot. I'm able to see the answer to my question visually. You have many options in your toolbox as a graphical designer, but when you're making your charts, you need to be careful. There are 5 ways listed here: omitting the baseline, manipulating the y-axis, picking which data to show, using the wrong type of graph, and going against convention. So let's look at some examples of how that might happen. Here we have a question: how many people agreed with the court on a particular decision? And we want to look at it by political party. If we look at this chart, we have Democrats, Republicans, and Independents, and we see that the Democrats way outweigh any decision by the Republicans or Independents in their agreement with the court's decision. But look at that y-axis. The y-axis actually starts from 50% and only goes up to 64%. That's not usual when reporting percentages. We go from 0 to 100. Let's see if we can fix it. Here we go. We have rearranged the axes and we have given some color to our political parties. In this case, we see that there's a far smaller gap between who agreed with the court amongst the political parties. And we only go to 80%, but that's okay. Enough to give us a visual picture that 62%, 54%, 54% are very close numerically. So a little over half of every party agreed with the court's decision. Omitting the baseline. Here, we've got some recording data for top artists on the left-hand side. Interestingly enough, we have Drake, can't pronounce that, Kanye West, Post Malone, Eminem, and the values there, number of views, etc. 21 million at the top and 11 million at the bottom. Well, it's very hard to distinguish what's actually going on there. So let's put it on a baseline we understand. We have bar graphs and column graphs for this very reason. Here we get a better visual distinction of what's happening for how many times these people's products have been viewed. We can manipulate the y-axis to have a graph show oddly. Okay, we have annual global temperature in Fahrenheit from 1880 to 2015. Notice on the very left-hand side, we're going all the way from minus 10 degrees up to 110 degrees, and it is very hard to distinguish what is actually going on in the temperature there. It looks like it might be going up slightly. Let's try to change the graph up to make more sense. Here we go. In the case that we're looking at the change and we're trying to show a pattern, it's okay to manipulate that y-axis to be a few degrees below where we have our pattern and a few degrees above. And we can see a better upward trend here across the decades. Now here is another bad graph. We're looking at wins per year for a particular sports team. In this case, University of Arkansas on their football wins. It is okay to say, hey, you're not going to play 100 games in a year for a college football team. At most, you probably play 10 to 14 games, maybe, and let's plot our chart there. So we changed up our y-axis to make a better readable graph. So evaluate your data, what you're trying to show ahead of time, and then pick your graph scales accordingly. Now, cherry picking the data. We're looking at, in this case, gross domestic product and UK national debt for the public sector for a period from 1995 to 2016, and it looks like things are increasing. Well, do you suppose that these are the only 20 years that this data has been tracked? I doubt it. If we're going to give the complete and accurate picture, as we do as technical writers, we want to make sure to show the whole picture. So from 1910 to 2015, you'll see that there was a much, much higher percentage of the national debt earlier on than there is now. So it was way higher, and now it's back on the upswing. Using the wrong type of graph. Here we've got a browser test to show that, wow, Microsoft Edge is the biggest, best, fastest browser that could possibly happen, according to Google's benchmarking system. If you read the small numbers, Google Chrome on the left says it's only 5% slower. Mozilla on the far right was only 9% slower than Microsoft Edge's. But look, the needle is pegged out for Microsoft Edge, not giving quite an accurate picture. Let's see if we can fix it. Let's look at it in a bar graph. Okay, wow. Speed score, whatever that happens to be, Edge barely beats out Chrome and by a wider margin Firefox. And again, if we look at a circle graph, Edge is a little bit bigger, but we'd have to know what the scale was to tell what the true story behind the data is. There's not much difference between these browsers at first glance this way. Number 5, the last one, is going against convention. Here we have an interesting question: which state have the most STIs, or sexually transmitted infections? If you read the source for this graph, the author actually comes up with some sort of score, and the higher the score, the lower the infection rate. Well, that is not usually how our eyes see these kind of graphs. We generally think of the darker colors being the hot spots and the lighter colors being the areas where there are fewer issues. Well, that's exactly the opposite here. So it tells a misleading story. Okay? So there are 5 ways we can mislead our readers with making graphs. And in the very first section, we talked about how to answer the question on our graphs in a straightforward way. We got rid of all those years that we didn't need, all those categories that we didn't need to answer the question, how has reading changed between 1978 and 2015? Okay, the end. This is the end of this slide deck, and stay tuned for the conclusion.
Well, that was interesting. I always enjoy learning new things, and we certainly did today about data visualization. We looked at how we answer a question with a graph, and we also learned 5 ways that we can mislead our readers if we don't correctly or accurately design our charts. So I hope you picked something up from this, and check your book, check online. You can always Google or use your favorite internet search to find more resources on the topic. This is all for this video section. Professor B out.